Siddhartha Basavajmali, studying in Sri Venkateswara College of Engineering, Bengaluru. Today I am going to explain about corrosion.
Corrosion. Corrosion is a process where the metal corrodes. Corrosion is a natural process, and in the presence of moist atmosphere, chemically active metals get corroded. Contrary to the popular belief, rusting and corrosion are not the same. Corrosion example: when an iron ore comes in contact with oxygen present in a moist air, a brown coat is deposited over it because of the formation of carbon dioxide. This is known as rusting of iron. When a silver ore comes in contact with oxygen present in the air, a black coat is deposited over it because of the formation of sulfur dioxide. This is known as a corrosion or trancing of silver. When a copper metal comes in contact with the carbon dioxide present in the air, a green coat is deposited over it because of the formation of copper carbonate. This is known as corrosion or trancing of copper. How quickly a metal rusts or corrodes can be described using something called Deal-Grove model. This model helps to predict and control the formation of layer called oxide in different situations. Types of corrosion. Uniform corrosion. Uniform corrosion is considered an even attack across the surface of the material, and it is the most common type of a corrosion. Pitting corrosion. Pitting corrosion is one of the most destructive type of corrosion, as it can be hard to predict, detect and characterize. Pitting is a localized from the corrosion in which either the local anodic point or most commonly a cathodic point form a small corrosion cell with a surrounding normal surface. Types of pitting corrosion. Through pits. First one is narrow and deep, shallow and wide, elliptical, vertical grain attack, sidewise pits, subsurface, undercutting and horizontal grain attack. Galvanic corrosion. Galvanic corrosion is the degradation of one metal near a joint or a juncture that occurs when two electrochemically dissimilar metals are in electric contact in an electrolyte environment. For example, when copper is in contact with steel in saltwater environment. However, even when these three conditions are satisfied, there are many other factors that affect the potential for and the amount of corrosion, such as temperature and the surface of finish of the metal. Large engineered systems employing many types of metal in their construction, including various fastener types and materials, are susceptible to galvanic corrosion if care is not exercised during the design phase. Choosing metals that are so close together as practicable on the galvanic series helps to reduce the risk of galvanic corrosion. Now let us discuss about some more corrosion types. Erosive corrosion. Erosive corrosion is caused by mechanical abrasion due to the relative movement between the metal surface and the corrosive liquid. In this, the surface of the metal gets deteriorated gradually by an abrasion of a fast-moving liquid, and cavity are also formed. This type of corrosion is commonly seen in a metal carrying more fluid in them. Fitting corrosion. Fitting corrosion occurs at the contact area of two materials that are joined together. This is usually appears when the contact area are subjected to slips and variations. These types of corrosion can be seen generally in bolted and riveted joint, clamped surface, and etc. Corrosion fatigue. Fatigue materials is defined as a failure of the material due to repeated use of stress if the fatigue of the material is developed in the corrosive environment. Then it is known as a corrosive fatigue. This can be improved by preventing the fatigue resistance of the material. Intergranular corrosion. Intergranular corrosion is a corrosion that appears on the granular region and the Grains are not affected in this case. It appears when there is a noticeable difference in the reactivity against the impurities between the grains and the grain boundaries. The difference in the reactivity appears due to the defective welding, heat treatment, stainless steel, copper, and etc. Now let us discuss the factors affecting corrosion. The factors affecting corrosion are presence of impurities such as salt, example NaCl. An increase in temperature increases corrosion. Exposure of the metal to air conditioning gases such as CO2, SO2, SO3, etc. Exposures of metal to the moisture, especially salt water, which escalates the rate of corrosion. An increase in temperature increases corrosion. Some oxides such as Al2O3 form an insoluble protective layer that can further stop corrosion. Other like rust easily disintegrate and exhibit the remaining part of the metal. Now let us discuss how to prevent corrosion of metal. Covering the surface of the metal with the enamel and a lacquer helps to protect the metal against the corrosion. Parts of our machines that move can be protected by coating layers of a water repellent oil or a grease. Another way of protecting iron and the steel is by painting on them, as it creates a barrier between the surface of the metal and the moist air or water. Whereas other methods of protecting a metal are alloying, galvanizing, electroplating, etc. Alloying. And alloying is a mixture of two or more metals. Alloying is a process where a metal like iron or steel are mixed with a less reactive metal like chromium, magnesium, etc. for protection against corrosion and to create a non-rusting alloy. Example, brass is an alloy which consists of a copper, is a cheap and non-reactive alloy. Another example of a non-rusting alloy is stainless steel, a mixture of iron and carbon. Galvanizing. Coating iron or steel with zinc to prevent corrosion is known as a galvanizing. Dipping a iron or steel in a liquid form of a zinc and using it as a negative cathode, zinc is coated on it. The layer is produced by electrolytic deposition. Zinc oxidizes or corrodes to create a zinc oxide layer that does not break off like iron oxide dust. Electroplating. Electroplating is a process where a metal is coated by electrolytic deposition with chromium, silver, or another metal. This process is generally held at a room temperature for aqueous electrolytes. It is one of the most popular and common method to prevent corrosion.